Hi students, in last session of successive differentiation, I discussed one problem. So to find the nth differentiation of a product, so it will be like this. So how to find the nth differentiation of this type of problem, e to the power of x into log x. We know how to find the nth differentiation of e to the power of x into sin ax plus b, or e to the power of ax into cos bx plus c, but we don't know how to find the nth differentiation of e to the power of x into log x. So there is some procedure to find the nth differentiation of a product of two functions. To find the nth differentiation of this type of functions, so just by studying a theorem, so that theorem is called Leibniz theorem. So Leibniz theorem, by using Leibniz theorem, we can find the nth differentiation of a product of two functions. Okay, so then what is that Leibniz theorem is, and what it states. So let us see. This is the Leibniz theorem, and this theorem states that if u and v are any two functions of x, if u and v are any two functions of x, so then to find its nth derivative of its product, that is y is equal to uv. So y is the function, it is a product of two functions u and v. U and v are functions of x. So then its nth derivative is defined like this. Nth derivative of uv, this is equal to nc naught into unv plus nc1 into un minus 1 v1 plus nc2 into un minus 2 v2. Like that it continues up to ncn into uvn. Okay, that last term is ncn into uvn. So vn means the nth differentiation of the function v. Okay, so there is no changes. If in place of u you can take v, in place of v you can take u, so it does not make any difference. Yes, to prove this theorem, so we can prove this theorem by the method of mathematical induction. You know that what is the method of mathematical induction is to find or to show some results which is defined to n values, that is so it consists of some n terms like that, to show that to prove that the results by the method of mathematical inductions. So in that method, first we show that result is true for n is equal to 1. So if that result is true for n is equal to 1, after that we assume that result is true for n is equal to m. And by assuming that result is true for n is equal to m, so then once again we prove that result is true for n is equal to m plus 1. If that result is true for n is equal to m plus 1, so then we conclude that result is true for any value n. Okay, that is the method of mathematical induction. So in previous classes you must studied that concept, the method of mathematical inductions. Here to prove this theorem we use the same thing. Yes, we prove this theorem by the method of mathematical induction. First you take the function y is equal to uv. So by method of mathematical induction, first we have to show that this result is true for n is equal to 1. Is here to show that it is true for n is equal to 1. N is equal to 1 means that is y1. So we need to find y1. Y1 means the first differentiation of y. So you take you just take the differentiation of y with respect to x. If you differentiate y with respect to x by using product rule, u into differentiation of v is v1 plus differentiation of u is u1 into v. Yes, if you take n is 1 here in this expression, it also gives the same. So for example, you check this. So just to take in the expression, in the statement of the proof theorem, you take n is equal to 1. If you take n is equal to 1, what happens? It gives y1. Y1 is equal to 1c naught into u1v plus 1c1 into, because n is 1, u1 minus 1 means 0 into v1. So that is, you know that NCR formula, NCR is equal to n factorial by n minus r factorial into r factorial. So NC not means if we substitute n is 1, r is 0, it gives 1. So surely it gives 1. So remaining here is u1v plus 1c1, ncn, mcm. So all that value gives 1. So it is u0 into v1. u0 means what? u1 means what? First differentiation. u0 means zeroth differentiation. Zeroth differentiation means, so we are not taking differentiation anta. That means we are not deriving that function. That u itself is called u0. So it is u into v1. So both gives same results. Okay. So that is y1 is equal to u v1 plus u1 v. So that means that result is true for n is equal to 1. Right? As now by assuming that this result is true for n is equal to m, once again we need to prove that this result is true for n is equal to m plus 1. For that, you assume that the result is true for n is equal to m. So that is, in statement you take m in place of n. ಕೊಟ್ಟಿರೋ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಎಲ್ಲೆಲ್ಲಿ n ಇತ್ತು ಅಲ್ಲೆಲ್ಲ m ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಇಲ್ಲಿ. So then ym is equal to mc0 umv plus mc1 um minus 1 v1 plus and so on mcm into uvm is to find. So to show that this result is true for n is equal to m plus 1, so we need to take this ym as ym plus 1. To means to get ym plus 1 we have to differentiate ym one time. So you differentiate this with respect to x. So then what it gives? Differentiation of ym is ym plus 1 plus mc0 is a constant, you keep that as it is. Differentiation of um is um plus 1 into v keep it as it is, plus um you keep it as it is. Differentiation of v is v1 plus similarly mc1 um minus 1 differentiation is um v1 as it is, plus um minus 1 keep it as it is. Differentiation of v1 v2 plus that series continues and so on mcr minus 1 into differentiation of um minus r um minus r plus 1 is um minus r plus 2 vr minus 1 as it is, plus um minus r plus 1 into differentiation of vr minus 1 is vr. Okay. So similarly this term mcr, by keep that constant mcr, you differentiate this, and finally mcm into this is u. Differentiation of vm is vm plus 1 plus differentiation of u is u1 vm as it is. Okay, this is ym plus 1. We need to simplify this one by using some formulas. Okay, before that you take mc0 into um plus 1 v plus, here this is um v1, isn't it? This is the term consists of um v1. Yes, this is um v1 and this is also um v1. You take um v1 common factor, remaining here is mc0 plus mc1 into um v1. Similarly here you take um minus 2 v2, this term, and um minus 2 v2 next term. Actually I am not written this one because it is not possible to write all the steps. You can imagine what is that next step is. So in that one you can take that um minus 1 v2 common factor, it gives that mc1 plus mc2. Similarly at rth term it is mcr minus 1 plus mcr um minus r plus 1. Here I am taking this term common factor, this and this term. Okay, so this term common factors, so it is mcr minus 1 plus mcr plus and so on. That last term is plus and so on. That last term is mcm into u1 vm, or you can take it as mcm into u vm plus 1 um plus 1. Okay, so next step we have is here. You remember that this mc0 can be written as mc0 means 1, m plus 1 c0 is also 1, m plus 2 c0 that is also 1. So I'm written this one because here in first term we have, so here you see this is MC naught. So in place of m you can write m plus 1, m plus 1 c naught. So then its value is unaltered. So ಏನು ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. ಎಮ್ ಸಿ ಒನ್ ಎಮ್ ಸಿ ನಾಟ್ ಜಾಗದಲ್ಲಿ ಎಮ್ ಪ್ಲಸ್ ಒನ್ ಸಿ ನಾಟ್ ಅಂತ ಬರ್ಕೊಂಡ್ರೆ. ಸೊ ವೈ ವಿ ಆರ್ ರೈಟಿಂಗ್ ಲೈಕ್ ದಟ್ ಮೀನ್ಸ್, ಸೊ ಜಸ್ಟ್ ಟು ಜನರಲೈಸ್ ದ ರಿಸಲ್ಟ್, ರಿಸಲ್ಟ್ಸ್ನ ಜನರಲೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಹಾಗೆ ಬರಿತೀವಿ. ಸೊ ಎಮ್ ಸಿ ಎಮ್ is 1, NCN is 1, m plus 1 c m plus 1 that is also 1. So and MCR minus 1 plus MCR can be written as m plus 1 CR, m plus 1 CR, you see. So you can write this MC naught plus MC1 is, so you can write both this term is, so you can club these two and write it is m plus 1 C1, like that it continues. This is m plus 1 C2, like that it continues. Okay, yes. Okay, so that same formulas, finally we arrive at m plus ym plus 1 is equal to m plus 1 c naught um plus 1 v plus m plus 1 c1 um v1 plus and so on. That series continues like that. So what is the next third term in right hand side is m plus 1 c2 u m minus 1 v2, like that. So that final term is m plus 1 c m plus 1, and that last term is um plus 1, so that is u into v m plus 1. Okay, so that means that result is true for n is equal to m plus 1. So this is the proof of Leibniz theorem. This is the proof of Leibniz theorem. So by using this we can find the nth differentiation of the product of two functions. So by the method of mathematical induction, so it is true for n is equal to m plus 1. So it is true for all the values of n. In place of n we can write any values. Okay, so like this we find the nth differentiation of a product of two functions. Is what is the application and to what type of problems you can solve by using this is, you see, yeah, yes, so already I told you that how to find the nth derivative of e to the power of x into log x. Here to find its nth derivative we can apply the Leibniz theorem. What that Leibniz theorem and how can you use this to solve this type of problems? Let us see how it is. So first to take the given function is some y. Okay, let y is equal to, let the given function is y is equal to e to the power of x into log x. Here you take this u is equal to e to the power of x, v is equal to log x. So does not so you can place u in terms of v, v in terms of u, so in the formula of Leibniz theorem, in the expansion of Leibniz theorem. Okay, so the nth differentiation of, if y is equal to uv, then by Leibniz theorem, its nth differentiation, so that is yn is equal to nth differentiation of uv is equal to, it is nc naught into uvn plus nc1 into u1 vn minus 1 plus nc2 into u2 vn minus 2 plus and so on. It continues like that, and in last step we have plus ncn into un v. Okay, this is the this is by using Leibniz theorem. So okay, you take that u is equal to e to the power of x, v is equal to log x here. If u is equal to, let u is equal to e to the power of x, v is equal to log x. So you can change that u in place of v in place of u. So ಹಾಗೆ ಚೇಂಜ್ ಮಾಡ್ಕೋಬೋದು. ಅಂದರೆ ವಿ ಅನ್ನು ಇ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಕ್ಸ್, ಯು ಅನ್ನು ಲಾಗ್ ಎಕ್ಸ್ ಹಾಗೆ ತಗೋಬೋದು, ತೊಂದರೆ ಇಲ್ಲ. ಸೊ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಕಾಮ್ಯುಟೇಟಿವ್. ಸೊ ದೆನ್ yn is equal to, so first you find what is u1. u1 is equal to differentiation of e power x, e power x. What is u2? Differentiation of e power x, e power x. So again like that, what is u1? It is e to the power of x only. If you know that formula directly, you can write it directly, no problem. What is vn? Nth differentiation of log ax plus b is minus 1 to the power n minus 1, n minus 1 factorial into a to the power of n. Here a value is 1, so not necessary to write that 1 to the power of n, by x to the power n. If you know the nth differentiation of v, we can easily write the n minus 1 the differentiation, n minus 2th differentiation of v. So if you substitute all these in 1 in this equation yn, so therefore nth differentiation yn is equal to nc naught. You should remember all these values. nc naught means it is 1. nc1 is equal to n. So this is because you see nc naught is equal to n factorial by n minus r. R means 0, 0 factorial into 0 factorial. So this becomes n factorial cancel with n factorial. 0 factorial is 1. So it is 1 by 1 is 1. And nc1 means it is n factorial by n minus 1 factorial into 1 factorial, which is equal to what? N can be written, n factorial can be written as n into n minus 1 factorial by n minus 1 factorial, which is there in denominator. You can cancel this n minus 1 factorial with n minus 1 factorial, right? So then what is remaining? nc1 is equal to n. nc1 is equal to n. So ಮತ್ತೆ ಹೇಳೋದಿಲ್ಲ, ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು. nc1 means n, nc0 is 1. So like that, nc2 is n into n minus 1 by 2. Okay, if you substitute all this here, yn can be written as, yn ಅನ್ನು ಹೇಗೆ ಬರೆಯಬಹುದು ಅಂದ್ರೆ, it is 1 into, so 1 into nc0 is 1 into u is e to the power of x. Vn is minus 1 to the power n minus 1 factorial divided by x to the power n, plus nc1 is n into u1 is e to the power of x only. Vn minus 1, if you know Vn, we can easily write Vn minus 1. ಏನಿಲ್ಲ, ಸೊ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಬೇಕು, ಎಲ್ಲಿ n ಇದೆ ಅಲ್ಲೆಲ್ಲ n minus 1 ಹಾಕಬೇಕು Vn ಅಲ್ಲಿ. ಸೊ Vn ಅಲ್ಲಿ n minus 1 ಹಾಕಿದ್ರೆ Vn minus 1 ಬರುತ್ತೆ. ಸೊ ದೆನ್ ಇಟ್ ಬಿಕಮ್ಸ್ minus 1 to the power n minus 1, that is minus 1 to the power n minus 2, and this is n minus 1 is n minus 2 factorial, this divided by x to the power n minus 1, that also reduces, x to the power n minus 1 ಬರುತ್ತೆ. So like that it continues. All of you know that ncn means it is ncn is 1 into un is e to the power of x, and v is log x. So that is yn is equal to, you can take e to the power of x common factor. If e to the power of x comes outside, what is remaining? It is minus 1 to the power n minus 1 factorial divided by x to the power n, plus this is minus 1 to the power n minus 2 factorial divided by x to the power n minus 2, plus and so on. That last term is, we are already taken e to the power of x common factor, this is log x only. Or if you write in reverse order, it also with the same terms, so log x plus and so on. So you can simplifying this one also by taking n factorial in numerator as a common factor. n factorial numerator common ತಗೊಂಡು simplify ಮಾಡ್ಕೋಬಹುದು, but not necessary. Stop here, it's not problem. So one more problem on nth differentiation is, it is a little bit interesting one. The nth differentiation of log x by x, nth differentiation of log x by x, as here also use our Leibniz theorem. So take let y is equal to, so let y is equal to, it is log x by 1 by x, or you can write log x into 1 by x. It is log x into 1 by x. Yes, here you take let u is equal to log x, v is equal to 1 by x. So then what is u1? u1 is 1 by x. What is u2? u2 is minus 1 by x square, like that. u1, nth differentiation of log x, is minus 1 to the power of n minus 1, n minus 1 factorial divided by x to the power n. So like that. What is Vn? Vn means its nth differentiation. It is in the form of 1 by ax plus b. 1 by ax plus b formally there. So Vn is equal to minus 1 to the n factorial divided by minus, so that is a to the power of n ಆಗೆ ಬರಿಬೇಕು, but a ಇಲ್ಲ ಇಲ್ಲಿ. So and n factorial divided by x to the power n plus 1. X to the power n plus 1, that is Vn. So by using the Leibniz theorem, we have nth differentiation of a product, so that is uv is equal to nc naught into uvn plus nc1 into u1 vn minus 1 plus nc2, this is 1. So nc2 into u2 vn minus 2 plus and so on, it continues like this, plus ncn is 1. Okay, you write that ncn into u1v. Yes, here you take this nth differentiation of u is log x, v is 1 by x, so or you can write log x by x, which is equal to nc naught, it is 1, u is log x, vn is, you write vn, so this is vn minus 1 to the power of n, minus 1 to the power n factorial divided by minus 1 to the power of n factorial by x to the power n plus 1 plus nc1 is n. You should remember that values. nc1 is n and u1 means differentiation of log x 1 by x. So n minus 1 the differentiation. So that is just idralle n anna n minus 1 ಮಾಡಿ ಅಷ್ಟೇ. That is minus 1 to the power n minus 1, n minus 1 factorial, this divided by x to the power n minus 1 plus 1, so that is x to the power n. ಏನಿಲ್ಲ, ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಬೇಕು, n plus 1 ಇದೆ, n ಆಗುತ್ತೆ. So plus similarly here, so nc1 means, okay, so I am written here, it is n into n minus 1 by 2, nc2 is n into n minus 1 by 2, differentiation of, that is u2 value is minus 1 by x square, ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದರೆ ಮೇಲೆ ಬರ್ದಿರೋದು ನೋಡಿ, ಇಲ್ಲ ಅಂದರೆ ಇಲ್ಲಿರೋದನ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ 1/x is minus 1/x square ಆ್ಯಂಡ್ ವಿ ಎನ್ ಮೈನಸ್ 2 ಮೀನ್ಸ್ ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಮೈನಸ್ 1 to the power n minus 1 ಇದೆ, ಇನ್ನೂ ಒಂದು ಕಡಿಮೆ ಮಾಡಿದ್ರೆ n minus 2 ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಸಿಮಿಲರ್ಲಿ ದಿಸ್ ಈಸ್ n minus 2 ಫ್ಯಾಕ್ಟೋರಿಯಲ್, ದಿಸ್ ಡಿವೈಡೆಡ್ ಬೈ x to the power, ಇಲ್ಲಿ ಕೂಡ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಬೇಕು, n minus 1 ಪ್ಲಸ್ and so on. At last term we have NCN ಅಂದ್ರೆ 1. UN, what is UN? This is UN, minus 1 to the power n minus 1, n minus 1 factorial, minus 1 to the power n minus 1, n minus 1 factorial divided by x to the power n, that is the nth differentiation of log x, into v andre that is 1/x. In next step you simplify this, which is equal to here you write log x minus 1 to the power n into n factorial divided by x to the power n plus 1 plus, and you see this n into n minus 1 factorial, n into n minus 1 factorial ಎರಡನ್ನು ಸೇರಿಸಿದ್ರೆ you can write it is n factorial, isn't it? So n into n minus 1 factorial, okay, ನಾನು ಇಲ್ಲೇ ಬರೆದಿರ್ತೇನೆ. So n into n minus 1 factorial means it is n factorial. For example 1 2 3 into some 6 or so suppose 3 factorial ಅಂತ ಕೊಟ್ಟು 3 factorial ಮುಂದೆ 4 into 5 ಇದ್ರೆ, so we club together, so and write it is 5 factorial. 3 factorial into 4 is 4 factorial. 3 factorial into 4 into 5 is 5 factorial. Like that n factorial, so n minus 1 factorial into n is n factorial. So and minus 1 to the power n minus 1 can be written as minus 1 to the power n minus 1 to the power n into minus 1 to the power minus 1 to the power minus 1. ಹೀಗೆ ಬರೀಬಹುದು, ಹೀಗೆ ಬರೆಯೋಣ, ಯಾಕೆಂದರೆ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತೆಗೆಯಲಿಕ್ಕೆ ನಮಗೆ ಈಸಿ ಆಗುತ್ತೆ. this divided by x into x to the power n is x to the power n plus 1, and similarly minus, so this minus I am written here, so ಇಲ್ಲಿ ಒಂದು ಮೈನಸ್ ಇದೆಯಲ್ಲ, ಇದು ಈ ಮೈನಸ್ ಇಲ್ಲಿ ಬರೀತಾ ಇದ್ದೀನಿ, ಮೈನಸ್, and also you see that n into n minus 1 into n minus 2 factorial, that can be written as n factorial. n into n minus 1 into n minus 2 factorial is n factorial. n factorial into minus 1 to the power n, minus 1 to the power n minus 2 ಇದೆಯಲ್ಲ, ಅದು minus 1 to the power of n into minus 1 to the power minus 2 ಹೀಗೆ ಬರೀಬಹುದು. this divided by x to the power n minus 1 into x to the power 2, ಇದೆರಡನ್ನು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ it gives x to the power n plus 1, x to the power n plus 1 plus, and so on. In last term we have, it is plus, you can write minus 1 to the power n minus 1 is minus 1 to the power n minus 1 to the power minus 1, and so here you multiply and divide by n, multiply and divide by n, so you multiply and divide by n. So now, so we are multiplying and divided by n because now n into n minus 1 factorial can be written as n factorial, n factorial divided by, so n factorial divided by, here x into x to the power of n is x to the power n plus 1 and n. So now you simplifying this, which is equal to, here you can take minus 1 to the power of n factorial divided by As here you take this minus 1 to the n factorial by x to the n plus 1 is a common factor. So then remaining here is log x plus, so you see here we have minus 1 to the power minus 1. What is minus 1 to the power minus 1? Minus 1 to the power minus 1 can be written as 1 by minus 1. So that is 1 by minus 1 is minus 1. So this term becomes minus. So you write minus here and we take that n factorial outside and minus 1 to the power of n outside and x to the power n plus 1 outside. So remaining is 1 here. Okay, now again here next term it is minus of minus 1 to the power 2, minus 1 to the power minus 2 is plus 2, minus 1 to the power minus 2 is plus 1. Okay, so and it is minus is there. We are taking n factorial common factor, minus 1 to the power of n is a common factor. Okay, so what is remaining here is so this is log x minus 1 to the power, yes, to make it is n, it is n factorial be taken. Okay, it is that anything left here, minus 1, so n into, okay, we forgot to write 2 here. Okay, this is n into n minus 1 into n minus 2 factorial is n factorial, and we forgot to write this 2 here. You write that 2, this 2. Okay, now if this minus 1 to minus 1 to the n and n factorial and x to the power of n plus 1 comes outside, remaining here is 1 by 2. So plus and so on. In last term minus, this is because I am putting minus here because minus 1 to the power of minus 1 means it is minus, and we take that minus 1 to the power of n and n factorial and x to the power n plus 1 common factor. So remaining is 1 by n. So this is the desired results. Okay, this is the nth differentiation of log x by x. That same result is asking here. Nth differentiation of log x by x is minus 1 to the n factorial by x to the power of n plus 1 into log x minus 1 by 2 plus minus 1 by 3 and so on minus 1 by n. Minus 1 by n. Okay, this is the nth differentiation of log x by x. Okay, so in next coming sessions, so let us discuss some more problems which can be solved by using Leibniz theorem. Okay, thank you.